In this video, we will learn how to solve a project by using deep learning. We will be solving this problem, identifying digits from images, and we will be doing submission so that our rank comes on the leaderboard. So this teaches you not only how to solve a basic problem with deep learning, but also how to use Kaggle and how to compete and get your score on this website. So first submission I did, it was an extremely basic submission, but it got a score of 92% accuracy, and in leaderboard, I was 1640. So by competing with this leaderboard, you can over time improve your ranking and you can map your coding skills of deep learning to actually applying it in a real life situation. Okay. So you might ask, why are we solving such a simple problem? Digit recognition is a 28 by 28 pixel, just 28. Okay, not 2 megapixel, not 28 megapixel, just 28 pixels. If we convert it into megapixels, the answer comes out to be 0.0007 megapixel. Such a small image. What are we learning by learning to classify such a small image? The answer is a neural network, if we simply increase in size, it increases the complexity of problem it can solve. So a network which can recognize a 0.0007 megapixel image can also be made to recognize a 10 megapixel by 10 megapixel image, and it might have 50 or 5 such objects in it. The key structure and basic fundamentals are going to remain the same. The neural network and its training, it's all going to be the same. What is going to change is the size of the network. So that is why we learn how to solve any problem by learning to solve a simple problem. So we experiment with simple a problem, and then we scale up the problem we are going to solve. Okay, so let's go into the code. For code, there are a few important rules. These are my personal philosophy rules. So I hope if you follow them, it will definitely help you in coding. First, write easy to read code. Most people do not write the code in easy to read way, and it everybody has that bad habit. Please kick it off. If you can write a code which is easy to read, you will have a lot of advantage in your learning journey as well, because you can read your own code better. Learn this, standardize the code in such a way that it is written in simple functions. So you call one function, for example, check this. I have written a simple function, get data sets. Everything is happening internally. I do not have to worry about anything else. So that way, whenever I'm executing the code, I can just immediately get working and start training the model. So make the code, standardize the code, put it into simple functions so that it is easy to use, and eliminate a lot of unnecessary code. In trying to beautify the graphs or in trying to do things, there is a lot of repetitive code which needs to be written. Try to minimize it as much as you can so that your code is easier to understand and manage. Okay, with these rules, let's go forward and start working on the code. These are the main packages: Torch, PyTorch library for writing neural networks. And then second package is Hugging Face datasets. This is a library in using which just in one line we can download all kinds of data sets, whether it is for computer vision or NLP. So that's why we use this. And then these three are, very common ones I use. Torch Vision, because we are related to image. Torch Info, I want to see what the model is internally. And Torch Matrix, which is just to calculate, even to get what is the prediction and how accurate we are. It has a lot of code which you have to write, converting probability to label. I wanted to simplify all that. That's why I use Torch Matrix package. Why? To eliminate the glue code, I try to use something to simplify my load. So these are the important ones. Let's check the main code. Instead of reading the image data from the Kaggle computation, I've used Hugging Face because it's standard, easy to do. So I've done Hugging Face low data set and specified data. This downloads the data set automatically. Simple thing. And then these are standard ways of transforming data set, which is of list of images, into numerical format. A image is now converted to a PyTorch tensor. So this is a standard code. This is list of transformations we want to do. This method to tensor converts every pixel into value between 0 and 1. So this is that function. So you might have some other transformations. And this is a simple function which converts a image. Example image is now converted into converted tensors. So very simple, easy to understand code, and everything is written just in one function. So in one shot, I get my data immediately, easy to directly available to train on. So this was getting the simple data set. Then step number 2 is defining a device which is going to be used to accelerate the calculations. The thing is, even a smallest of neural network will have 10,000 parameters at least. So if when you're doing calculations, it's going to be 10,000 dimension long vectors at minimum being added and multiplied. And at maximum, it could be 1 billion elements in an array. So it's not possible to run it on a simple CPU because it's going to be very slow. That's why device is so important. This is what we are going to use to accelerate our training. Trust me, this is the most important thing. Without a powerful GPU, model training takes infinitely long time. So that is step number 2. And then step number 3 is writing a extremely simple neural network. I have taken a simple image, 28 by 28 megapixel, flattened it into a 2D thing. So each layer's output is going to be something. And it's just 3 layers, 2 hidden layers and 1 output layer. So first layer is this. Out features means number of neurons. And so at first layer has 20 neurons, second layer has 15, then final has 10. So a very simple neural network, and anything which you initialize is randomly initialized parameters. So when I specify this, each neuron, now there are 20 such neurons, each neuron has some randomly initialized weights. And those are what we are going to learn when we train the model. So we send it to the device, and when we say torch summary, this will print the details of everything. So first layer, it has input of something and output of something. So all the details and parameters you will find. The small network has 16,000 parameters. Okay. And then comes training part. Training code I have written in such a way that it makes it easier to understand what this whole thing is. Our aim is to find out relationship between the error. What is error? We make the model predict something, and difference between its prediction and real answer is error. So what we do is we calculate error with respect to every single parameter here, all 16,175, and we adjust these parameters so that error reduces. So what are we doing? We are hacking. We are just changing the parameters value to artificially find a place where error is minimum. And if we reach low enough error, we have a a neural network which gives us quite good accuracy. If it is less error prone, it is more accurate, right? As simple as that. So by using dumb device calculation, we are in an extremely simplistic way finding out the correct answers. Any problem can have infinite neural networks with different weight values, all with similar low error. But so that's why reaching any value works. So error function is how we calculate the error. This function torch.autograd calculates the error rate of change of error with respect to inputs. Take a look at how I have written the code. I've written it so that everything is easy to understand. First, I take the list of parameters to optimize. Second, this is the package which is gonna optimize the parameter values. I said these 16,000 parameters are gonna be juggled and we are gonna find a permutation and combination of minimum error. Who is gonna do that? Torch.optimizer. All the code is written for us. We are simply using these elements. So optimizer, we kind of like initialize here. Error is defining that error thing. And actual rate of change of error with respect to all the weights is like this. The actual code goes like this. Very simple. I have a certain number of epochs. Epochs is how many times I'm going to repeat the same data. Why do we repeat the same data? These neural networks we have written are so inefficient that even with 60,000 images for handwritten digits, even with 60,000 passing images, it doesn't learn. It needs more images. So we pass them again and again and again. So 60,000 images 10 times means 6 lakh, right? So we keep repeating because learning rate is so inefficient. Learning rate is so slow. So I use torch metric function accuracy here because it makes it a lot easier to find out the accuracy in one line. So I initialize the metric here, then going through data loader, simply downloading the data and sending it to device. These are things you have to track. That's why I have tried to standardize the code so that we can simply start running whenever we want. Then we take this value, predict the output. We calculate the error with respect to this thing. So you see output which was predicted here and y actual, which is the actual value found. And we simply calculate the loss and then two main important functions. Calculating the error with respect to all the parameters it has, 16,000. This whole thing is done by this simple one line, loss.backward. So a lot of thing is happening in the background. Everything is being done by this. You can either do this or you can do DE of error underscore weights and torch autograd, and this will also work fine. Then updating all the 16,000 parameters. See, you're not updating just one. You're updating all 16,000 parameters. This updates all of them. So there is a lot of thing which is happening internally, but for us, it is just one line. If you want to write this whole thing in more detail, you can write the code like this. So what we do is for each parameter in the model, there is a associated rate of change of that parameter with respect to the error function. So 16,000 times this for loop is going to get executed for this model. And for each parameter, it could be a part of a vector, weight vectors, or it could be bias, whatever it may be. For each of them, we are going to do this update. This optimizer step does that. So this is such a simple way of using a machine to ensure that we are minimizing the error. And we keep doing this and we arrive at a really amazing solution. So calculate the error values. And then here I simply calculate the accuracy. In PyTorch, this takes a different complicated number of lines. I have simplified it by doing simple this thing. So we calculate the batch accuracy and then we also calculate its average. This guy does that average calculation. Okay. We print it into a dashboard. This dashboard is weights and bias. Again, all the standard things you need in all deep learning codes. And then we do the reset and we evaluate the model. So a standard simple block. Let me execute this. It asks me to put a security authentication code. from a place where my training I am going to monitor. The place is weights and biases. This is the website. Really nice websites. All data scientists use it. Very good to track all the trainings. Let's copy this. Let's paste it here and execute. So when you want to build a different model, you can directly go here and change the model definition. Everything remains the same. That's why I've written this whole code in such a way that it becomes extremely simple for anyone to take this further and experiment and get used to the understanding what is neural network. So everything is explicit, nothing is happening implicitly. Everything is easy to read and code is very simple to follow and many minimum number of lines. Okay, this will take whatever time it will take. You can monitor it, and this is why we did weights and bias. It tracks everything for us in a really nice way. So you see, what we are doing is we are going through the entire images one by one. In this case, we take a group of images, and for each group, we do prediction. And for each of that group, all the parameters is 16,000. So if the model is bigger, it will be those many parameters. So we do those many dimension calculation, update those many weights to reduce the error. And as you can see here, you can immediately see as and when time is going, the accuracy is increasing, training accuracy. So model is getting a bit better at prediction. You can see it immediately from here. Error is reducing and accuracy is increasing. So such a simple thing works and such a simple model works. We only have to build on top of it, refine it. And even if we are scaling to a more complicated problem, even then this neural network and training and the concepts, all of this fundamental remains the same. So a very simple code end to end, it will allow you to execute thing immediately, and it will allow you, most importantly, to do Kaggle submission and immediately check how good your experiment is. So to do that, this is simple pandas code in which you read the file on which we are going to test the prediction. A simple thing so to get the predictions, and this is the prediction code wherein we pass the model, PyTorch model. Mm, this is the PyTorch model. I wrote the function wrongly. So model, we do predictions. From predictions, we find out what is the label. So you see, we start a lot of code, torch, max, and something and something. So these codes make it a bit difficult to understand what is happening. But pay attention, and over time, you will understand everything, and then you will be able to make changes wherever required, and you can start working on a complicated projects. That's why we did all this. This, when we execute, will build a submission file. And when you do that submission file, where can you find it? Go to the right side. And here in the output part, you will find the file which you have built. So just download that submission and simply submit your predictions by uploading the file, and you are good to go. So in less than 20 minutes, if you follow this tutorial, you will be able to write a end-to-end neural network code on a problem, do a prediction, submit those solutions here, and get your rank on the leader. So pretty good for a half an hour video, right?